Let's do a recap of what we have. Get a nice big grid going. So if I have two charges or one charge, a vector or scalar. So if I have two charges and I'm talking about a vector, we can talk about force. Electric force 1 on 1 from 2 is equal to k q1 q2 over r squared r2 hat. If I'm dealing with only one charge, I can't talk about force because forces require two objects. This has only one object, but I can talk about the electric field. kq over r squared r hat. When I'm talking about two charges and a scalar, I can talk about energy because the electric potential energy is k q1 q2 over r. And we have a blank here. So there has to be something involved. So let's talk about that a little bit. Sort of also in the recap here, I know that the unit of the electric force, the SI unit, is a Newton. The SI unit of electric field, Newton per Coulomb. Unfortunately, they don't have a single name for that. The unit of electric potential energy, or potential energy in general, is the joule. That's the SI unit. We got the electric field by just dividing by one of the charges. Well, we can do the same thing here. If I take U and I divide by a charge, then I can get something there. In essence, that's what we do. So if we take that, divide by a charge, I'm just left with kq over r. Now this is known as electric potential. Please do not confuse it with this, which is the electric potential energy. Now in the past, I have used the term potential to mean potential energy, but I can no longer do that. And I apologize if that's going to cause confusion here. But if I'm talking about the energy, I need to say the word energy now. If I'm not talking about energy, then I will not use the word. And so sometimes the word electric is just left off because of context. If I just say, hey, what's the potential? This is what we're talking about. The symbol for it, I'm going to hold off on just a second. The unit, since I divided by a charge, the SI unit of this would be, well, I just divided by a Coulomb, so that's a joule per Coulomb. And that is too much for physicists to write, and so they came up with a word for it, and that is the volt. And here's the lovely part in physics. The fact that this is a volt, the symbol for electric potential traditionally is a capital V. These two V's do not mean the same thing. This V is electric potential, this V is volt. This leads us into the idea that in physics, I can write the equation 5V equals 5V. In math class, this means V is equal to 0. However, it's not math class, this is physics, and these two V's mean different things. It would be really nice if they had different symbols, but they don't. So this is the electric potential, and this is volt. Please note, I have not talked about voltage yet. All I've talked about is electric potential and volts. Voltage is something that's related to it, but a little bit different. Let's say that I have some point here that has a value of 5 volts. I have a point here, which is 4 volts, a point here, which is 3 volts, a point here, which is 2 volts. I take a particle here and it moves from here to here. What is the change in electric potential? Well, it's always final minus initial, so that's 4 volts minus 5 volts, which is negative 1 volt. This is known as the electric potential difference. If I start at this 5 and I move to here, what is the electric potential difference? Or change in the electric potential? Well, in that case, that would be negative 2 volts. If I took it from 4 to 2, that would also be negative 2 volts. Now, if I start at the 4 and I go to the 2, but then I come back over to the 3 and then to the 5 and then go around and end up at the 3, what's my change in potential now? Well, I started at the 4, I ended at the 3. Whatever happened in between does not matter. So that big, long, convoluted path, the change in the electric potential is negative 1 volt. This electric potential difference is also known as voltage. So if I have a 12-volt battery here, say it's 12 volts, what I'm saying is that the potential difference between the two is 12 volts. I am not making a claim at what the potential is here or the potential here. All I know is that the difference is 12. So if this is the positive side and the negative side, if this is 0 volts, well, that's 12 volts. If this is 100 volts, that's 112 volts. If this is 0 volts up here, this would be negative 12 volts down there. What we find is that what really makes a difference is this change in potential, because that is what causes charges to move. If there's a difference in potential between two spots, it's going to make it try to go from one spot to another. That's leaping ahead a little bit, but just sort of a preview of what's going on.